Okay, hello everyone. I want to thank you all for attending today. My name is Donald Danroth, Sales Coordinator for Lumex Instruments Canada. I hope everyone is having a warm and safe festive season. Today you'll be hearing from our CEO, Dr. Maxime Slyadnev, as well as our Head of Research and Development, Dr. Sikander Gill. First, Dr. Gill will be giving us an update on some new COVID-19 detection microchips that we have to offer. Then, after a brief introduction to our company, we will be jumping into the operations of our microchip-based real-time PCR analyzer. Please feel free to use the chat provided to ask a question at any time during the webinar. All questions will be answered after the webinar. Be sure to stay until the end where we will have a live Q&A session with Dr. Slyadnev. If at any time your video is frozen, please refresh your browser. Thank you everyone and enjoy.
Well, in the wake of the current pandemic situation going around in the world about COVID-19, Lumex Instruments Canada has developed a real-time PCR-based microchip test, which employs US CDC designed RT-PCR assays. And primary proofs of those assays, they are available from IT USA as research use only or emergency authorization use purposes. So those primary probes, they are preloaded and dried in the microchip to add user friendliness to the microchip. And this microchip involving 3 targets as single plex can do 7 samples along with negative extraction control, positive control, and the negative control. This microchip assay has been validated by a local university, and a manuscript has been submitted for publication to a journal. To this microchip, we have to add nasopharyngeal sample extractor RNA. So this means that there is an upstream step of RNA extraction from the sample, which is cumbersome and time-taking. So to add more user-friendliness, we have developed extraction-free sample where saliva can be simply used into the microchip after simple procedure of processing. And in addition to that, we have developed a microchip which can do 12 samples in addition to NEC and other controls. So in this chip, 2 targets, N1 and HSRPP as internal control, both are used as single plex. And now we have recently developed another microchip which has 2 plex detection system, N1 and HSRPP as internal control. And this microchip can do 28 samples, 1 negative extraction control, along with positive and negative controls. For more details, please contact Lumex Instruments Canada. Thank you.
Hi there, my name is Maxim Slyadnev. I am the president of Lumex Instruments Canada. And today on our webinar, we will be covering our state-of-the-art microchip-based real-time PCR instrument, AriaDNA. Let me start with the introduction of our company. So our company started several dozens years ago, and right now we are proud to be #1 in the portable mercury analyzer market. On top of that, we produce more than 6 marketing product lines, and I will show you the details on my next slides. So worldwide, we covered by more than 60 patent applications and active patents. And our team of R&D and designers represent more than 10% of PhD degree holders. We serve more than 90 countries in the world, and our application range covers more than 200 applications in different industries. We operate through 5 offices in the world, and some of them also cover manufacturing of our product lines, and some of them are just sales offices. But as you see on that slide, we cover most of the globe. We represent our Vancouver-based headquarters in the North America, covering both Americas and Oceania from here. And we have also manufacturing facility in St. Petersburg, Russia, and 2 other sales offices, one in Hamburg, Germany, one in Beijing, China, covers the rest of the world. We also work through the quite extensive work of our distributors all across the globe, representing our products on all continents, and as I said, on more than 90 countries. So our list of users are quite extensive. And let me show you just a few of them on that slide, covering different industries such as food and beverage, environmental and water, agriculture, academia and research, and some other industries as well. We are proud to represent several state-of-the-art lines of our analytical equipment. And let me start with our well-known fluorimeter named Fluorad. So it's one of the well-known instruments in laboratory settings across the world. Here on that slide, we also are present in several of our infralume analyzers, infrared Fourier transform-based spectrometers, designed to fit industries such as grain analysis, food and agricultural applications, as well as laboratory analyzer infralume FT08, which covers mid-infrared range. And one of the state-of-the-art graphite furnace atomic absorption spectrometer with Zeeman background correction is also present on this slide as one of the lightest in the world, and delivers very fast atomization rate and very significant background correction, as you see in our applications. But let me continue and show you our Capel 205, the capillary electrophoresis equipment, which basically installed in laboratories dealing with quality of food and beverage, environmental protection, water quality applications, and pharmaceuticals and life science applications as well. Our mercury analyzers are represented here by portable mercury analyzers and continuous emission monitors in natural gas and in air. With some attachment, this type of mercury analyzers can extend the samples to solid samples and to aqueous samples as well. And today, our focus of our webinar will be microchip-based real-time PCR analyzer AriaDNA. And the head of R&D department, Dr. Sikander Gill, will have details right after my introductory part. But let me say that we are not only producers of analytical instruments. We also develop and install more than 150 applications in different industries. And this slide shows that we have a lot of application in food and beverage and agricultural industry, also in water and environmental, academia and research, and some other industries as well. And today we will be talking about real-time qPCR applications, and as you see, they represent quite a large portion of it in our application portfolio. So we are a growing company, and as you see, our milestones on that slide, we grow from 60% of market share in portable mercury analyzers through the recognition in capillary electrophoresis equipment and fluorimeters, up to gaining market share in capillary electrophoresis and real-time PCR application in life science industries. So let me pass the word to the Dr. Sikander Gill, who will be focused his presentation about microchip-based real-time PCR analyzer. Thank you for your attention.
Hi, my name is Sikandar Gill. I had my PhD from Dalhousie University, Halifax in Nova Scotia. And for the last 4 years, I'm working with the Lumex Instruments Canada. My major role is to develop applications for microchip-based real-time PCR technology of this company. Well, in today's video, we are going to cover two aspects of this technology. One is extraction of genetic material, DNA or RNA, depending upon your project. And second part would be about liquid handling or the sample addition into the ready-to-use microchips or empty microchips, and then running the PCR on AriaDNA DNA analyzer. Okay, for every kit, you have to follow the specific instructions, whatever is specified by the kit producer, kit manufacturer. And here I'm just going to demonstrate only the major steps of paramagnetic bead-based method or magnetic bead-based method. And here in this tube, I have already incubated the crude extract from the sample. And now I'm going to add 20 microliter of the magnetic beads. So they should be properly suspended. And after good suspension, then I'm going to take 20 microliter out of this and add to the sample. So after mixing it for about a few seconds and then let it incubate for about 30 seconds to 1 minute, and we are allowing the nucleic acid to bind to the paramagnetic beads here. And after sufficient time, now I'm going to separate the magnetic beads from the sample. The moment I put into the magnetic block, the magnetic beads, they are pulled towards the magnet, and the supernet is having the junk in it. Now it can be simply, now there may be some magnetic beads on it, so you can do like this so that the tube is clean from inside of it, and then I can simply dump it out here, and you're left with magnetic beads in this way. So now going to add the wash buffer is this one, mix it. And now these beads, they have to be mixed very briefly, and then put it back in here. Do once or twice like this to clean the tube from inside. So now the same process, the beads are attracted towards the magnet here. So now dump the liquid out. So now is the turn of the next buffer. Again, close the lid, take it out, mix it briefly, then do like this to clean the tube from inside again, and now again the same thing, and dump it out. So we have to repeat the process 2 times. So this is the repeat of this second wash. So these washings, they have to be done a little quickly because we don't want to shake them too much to remove the DNA, RNA from the beads, because some of them may be lost from the beads if you're doing too much of mixing here. Now it's again the beads are attracted towards the magnet. There is hardly any liquid, and if there is any liquid, you can remove it before taking it to the next step. Next step is to dry the magnetic beads in the incubator here. The purpose is because there is some alcohol in this buffer, and you want to remove all the traces of the ethanol alcohol from this one, because this happens to be an inhibitor of PCR. So we are going to give about 8 to 10 minutes as per the kit, and the magnetic bead, they would be sufficiently dry and free from the alcohol. So now it's time to elute the sample. Microliter of it, elution buffer, and put it into to better mix it, we can use pipetting action. You can again incubate it for about 2 minutes to be taken out, and we will mix it 2 or 3 times and then bring it to the magnet block, and we can clean the tip from magnetic beads if any, then extract and put it into the DNA or RNase free and label it. Introduce Dr. Raj Gill. She works as a research scientist in this laboratory, and now I'm going to pass on the isolated purified DNA from the sample for addition into the real-time PCR microchip, and so I passed on to her.
Okay, I will add this sample to the ready-to-use microchip. Then that microchip will be loaded to the AriaDNA for testing. This is the ready-to-use microchip. The microchip is enclosed in this pouch. So I will tear it off from this side and take out the microchip. Okay, I'm putting the microchip into the adapter like this. Then I put oil over the microchip. So I'm adding 620 microliter of oil. This is a multi-channel pipetter to add sample. And I add water in the positive controls. And the chip is ready. Okay, so now we will load the chip to the AriaDNA. So open the drawer and put oil. And load the chip. So after loading the chip, you can open the project from the projects, and you can name the experiment number demo 4. You can describe the chip, food path chip, and you can put the samples in the template. Sample number 1, sample number 2, sample number 3, and in controls we added water, and then you can run the analysis. So it will give you results in 30 minutes. Okay, analysis is running and it will take about 30 minutes to get the results. And if you have any questions, concerns about preparing the microchip and loading into the AriaDNA, please send us email, or you can go to our website www.lumexinstruments.com, or if you want to see more details of the results, you can check our another video. Thank you for watching the video.
In today's video, so I'm going to show you how to analyze the data which comes from the microchip real-time PCRs. Okay, so as you see in this interface, basically the microchip which we use, that was ready to use, that means it has all the reagents dried up, lyophilized in it, and there were a panel of 11 pathogens which you see here, all the 11 pathogens in here, and they were arranged from this side to this side, like the first and second, third, fourth, fifth, sixth, 11th, and this is the internal control. So the whole of this row, that makes one sample. So second sample, which shows by the green color in here on the top of it, so this shows that this is the second sample, and the red color on all the wells here, so is the third sample, and corresponding to the same is the negative control for these two pathogens, negative control for these other two, and negative controls for the third pair, fourth pair, fifth pair, and the sixth one. So this is of course the internal control, negative control for internal control. And in this row, these are all positive controls, again for each of the pathogens. So this means that there are negative controls here, all the positive controls here, and internal control in this column, and the rest of them, they are the sample. Now in today's video, what Raj ran is that she ran only one sample but repeated it 3 times. So this means we are expecting a kind of 3 replicates from the same sample. And so those results, they are shown up qualitatively. This V mark in the negative control, this means that they came very good. And similarly, the positive controls, they are also showing very good. Had there been other way around, means some positive control didn't work or negative control didn't work, then they would be X mark instead of the V. And same thing is for the internal control. As you see that the internal control is reported positive, positive, positive. So this means the sample got good extraction. That's why the internal control showed up. But the none of those pathogens was there in that particular sample. So that sample was neat and clean. So only internal control reported. And the same story in place of the color codes here is reported in this table. The names of the different pathogens in the panel, they are right here. And sample, unknown sample 1, unknown sample 2, unknown sample 3, controls and negative control and positive control. So they are just similarly reproduced in this table. And this is the panel which I said earlier also, that these color codes, they are representing the names of those pathogens. So this is what we see qualitatively. Now let's look at quantitatively. So when we click on to this quantitative window, again the same set of pathogens are here. The whole panel is represented, and in this window the controls are presented like positive control, negative control, and the unknown samples. And here are different samples represented here. And again in this area, the whole microchip is represented, means that in case I click any of those, the same curve, corresponding curve, that would be going off from this window. Yeah, okay, so now let's look at the quantitative picture of the data. And so for that, we will click on to the quantitative window as I just did. And now in this interface, you see the amplification curves, which are grown up or which have died down. And in this window is the whole panel of pathogens. In this window is just the consolidated picture of positive control, negative control, and unknown. Means in case I click any of those, then the corresponding curves, they would disappear from the amplification curves. And here are, in terms of the samples, sample 1, sample 2, sample 3, then 4th and 5th, they are negative control and the positive control respectively. So in this area is the whole microchip represented in terms of that which well you want to click off to see the corresponding data in the amplification curve, like that. And below in here, they are the names of the different pathogens, and you will see the CT value along with, in case there are replicates, then it will show you the CV%. Otherwise, if they're in single, then you don't see any CV% there. So CT values, they are represented there, and names here, the corresponding well is here. So this means that the data can be analyzed from different angles, and it makes very user-friendly to see what you want to really see in just a nick of time kind of things. So let me show you now as an example. Suppose I just want to see only the unknown samples. So in unknown samples, you see that the rest of the data is gone off, and what I see is only 3 curves. And these curves, whether they are from the target or from the internal control, let me click off, say, target. So only target is there. So this means there is no fluorescence units reporting here. And this means the sample doesn't have the positive sample in there, none of those pathogens. But how would I make it sure that, okay, it's the right data? So let me go back again to the internal control. If internal control is there, yes. All the 3 internal controls, they are reported. One is, say, from here, another is from here, another is from here. So all the 3 samples, of course the same sample repeated, but they are showing internal control reporting. So this means that PCR did work, but the sample doesn't have any of those pathogens which are tested in the whole panel. Now let's go to only the negative control. So let me take it off the unknown ones and only the unknown samples. So none of the curve is crossing very minor fluorescence units. So this shows that negative control, they went very nice. Now let's look at the whole panel of positive controls. Again, I will take it off and show only the positive control. Now from here, so I can see, okay, in the first well, in the second well, in the third well, in the 4th one, in the 5th one, and in the 6th one. So this means that all the positive controls, they are reporting, and you can also see for each, say whether which of them is FAM and which of them is CY5. Means this is from the second channel, this is from the first channel. Again, if I go to another well, just to give you an example, again if I click it off, this is FAM, means the first channel, and the other one is from the second channel, like that. So this is how, similarly you can also see click off that if I want to see this particular pathogen, if I click it off from the whole of this, so you will see only the corresponding pathogen showing up. So this means you can analyze the data in terms of positive controls only, negative controls only, unknown samples only, or particular pathogen also. You can click particular pathogen name, you will see where, in which well it's there, and which corresponding curves they are there, and the CT values, they are also at the bottom. If you have any question, so please let us know through our website. We would be very pleased to get back to you with the possible answer. And so thank you very much.
Hey, hello everyone. Thank you for tuning in to the webinar. If you have any questions, please write them in chat, and Dr. Slyadnev will be happy to answer them. Thanks again.
Hi there, everybody. So
Okay, I see the question here. Which extraction kit was used during the presentation? I think during presentation we have used extraction kit which utilize magnetic beds, and this technology represented on the market by several commercial manufacturers. And particularly in this case, we used a European manufacturer, and our sales team can contact you in order to clarify what was the details of that particular kit.
Any more questions, please write them in chat. Thank you.
Okay.
Okay, if there's no more questions, then I'll give everyone 30 more seconds to write questions.
Okay, I can voice over this comment from Dr. Sikander Gill. He is quite right. The spin column based kits are equally good for extraction, and we showed that AriaDNA technology, AriaDNA platform is well compatible with those spin column based kits. And actually, related to COVID, we utilize those commercially available kits in our instruction for use. So RNA from SARS-CoV-2 virus is extracted using spin column based kit.
Okay, I want to thank everyone for joining today, and I want to wish everyone a happy holidays and a warm and safe festive season. Thank you, everyone.
Yeah, thank you everyone for joining us. Thank you. Stay safe.
If you would like a downloadable version of this webinar, please contact myself, Donald at lumexinstruments.com, or Alvin Johnson. Thank you.